Hi everyone, I'm Martin Wennerblom, Marketing Director of InMotion Technologies, part of the SAPI Group companies. I would like to welcome you to this session. Please remember that this session is also being recorded and will be available to watch on demand following the session. If you have any questions during the talk, please add them to the Q&As part. You can see that tab to the right of your screen. Note that all of the questions will be sent privately and moderated during the session. So with that, I would like to introduce our speaker. I would like to welcome Shuang Zhao, our safety manager here at InMotion, who will be speaking today about tips for a successful and cost-effective ISO 26262 project. Welcome, Shuang. Please take it away.
Okay, thank you. So first, welcome everybody to join this virtual event. Today I'm going to talk about something. It's more like some experience we have learned over the years from variants of customer projects we developed together with the customers in automotive industry following ISO 26262 project. So probably the topic is a kind of a big, so it's kind of really difficult to cover all the tips for a successful and effective project. So actually today I'm going to focus on talking about the collaboration between the OEMs and the suppliers. So it's not focusing on the product development as a supplier. So you can say that this presentation is sort of license learned. So it's something we have seen and heard in the projects, some mistakes or something we feel like can be really improved in order to make the project running smoother and more cost effective. So today I will just cherry pick the personally top 3 things that I would like to address. So the first, having a good communication is very important in a functional safety project. Miscommunication can cause lots of problems, not only at the beginning of the project, but it could also lead to major changes in the end of the project when everything is too late. And if you have such miscommunication and it cause a big change in the end, then very likely the project will be delayed and also the cost will be increased. Another one is that we see some incomplete safety concept handed over from the customer to the suppliers. One thing is that it could be like a practical thing to do, that you are developing the functional safety concept while the project is progressing. But the thing is that if the functional safety concept has not really well thought through before the project starts, then you have a big risk that you realize that something really have to be changed at the end of the project. And sometimes simply the functional safety concept is not so sufficient. And that is also probably due to the first problem, a miscommunication at the beginning of the project. And the third, but not the least, is late changes. And this is a common cause for a project delay in any kinds of development. And especially in functional safety projects, late changes may result in bigger consequences. So I have some examples to show you at the end of the presentation. So please stop me if you have any questions. So I've been trying to adjust the level of this presentation because it's a little bit hard to really explain everything in this 26262 standard in such a short time. So if you feel like I'm talking a little bit too deep, then please stop me so I can adjust the level accordingly. So speak functional safety language to avoid the miscommunication or misunderstanding between each other is something feels quite obvious. So why you are talking about it? And the reason I'm talking about it is that we have experienced some difficulties. And also our OEM has experienced some difficulty. So it's kind of hard to understand each other in a perfect way. And the reason is that different companies has different terminologies. And when people talk in the technical terms, you prefer to use something that you are familiar with. And also the people working in a functional safety project, they may have different backgrounds from other industries. And also they probably have worked within the functional safety area, but with another safety standard. So when you sit together with other functional safety engineers working in 26262, it's very, very important that we use the same vocabularies, which is defined in the part 1 of the standard. It feels like a lot of companies overlook part 1 in the standard. It has 46 pages, so it's not very long. And you can find 185 terms and definitions quite clearly explained, and also you can find the notes and examples. So one example is that we often heard the term safety function from some of the customers. And it feels like those people have a lot of experience with the ISO 13849 standard because you talk about safety functions a lot in that standard. But the safety function is simply not a term defined in ISO 26262. In this standard, we talk about intended functions, we talk about the safety goals, we talk about the safety mechanisms. So when you talk about the safety function, then it doesn't mean much to a supplier, to be honest, because you also have to tell the supplier, is that safety function an intended function I want to achieve? Or it's simply a safety mechanism that we need to use at a higher level, so please implement it. Well, if you haven't worked with the standard, then probably you don't know why I'm really oversaturating this, but actually it matters a lot, because if you do not specify what do you mean by safety function, is that a function or is that a safety mechanism, then the difference could be day and night. I will probably have some examples later on in the presentation to show you what do I mean. And also this standard has so many parts. It has 12 parts that covers the concept development, safety management, product development, hardware development, software development. So part 1, those vocabularies sometimes is even not sufficient. So we also have to study the rest of the parts in order to talk the same language. And over the years, we see a lot of misunderstanding or a little bit incorrect interpretation of certain terms. And since this presentation is focusing on the conceptual development, so at least the top things, so which are the item and element, and the understanding of the hazard analysis and the risk assessment. What is safety goal? How is the ASU derived? What is a safe state? And what is the difference between functional safety and technical safety? Also, there's a common thing that we have seen, that the OEM usually focus on the software development. So they are the system integrator buying different systems. and then come up with a conceptual design, and then implementing the software to bridge all the systems together to fulfill their safety goal. So sometimes they are not the experts in the part 5 of the standard, where it specifies the requirements for hardware development and the verification, etc. So then you forget that in order to show the evidence that you have fulfilled your safety goal, you also have to calculate some numbers. And those things are specified in part 5 of the standard. So when you hand over functional safety requirements to the supplier, you really have to think about what the suppliers need in order to provide you those numbers in the end. So we have to wear each other's hats. We have to think from a different perspective in this project. So what are the items and the elements, and why we need them? Actually, it's quite critical to have a really nice and clear item definition in order to start your conceptual design, because the requirement requires us to do a hazard assessment, a hazard analysis, and the risk assessment for the item that you have identified. So if you look at the standard, then there are some gray area between the item and the elements. And also it provides some flexibility for defining an item. So the item is a system or a group of systems implementing a vehicle level function or a part of vehicle level function. So my proposal is that if you are new to this standard, then it's better to define an item that is implementing a vehicle level function, not a part of it. Otherwise, you will have a really difficult time to do a HARA later on. So what is a vehicle level function? A vehicle level function is a function that is observable by the driver or the passengers or other road users around that vehicle. So we have seen some item definition that is specifying a part of the vehicle function. It's not something you can observe as a driver. So some very simple example of an item that is defining a system to realize a vehicle level function. The traction system can be an item where you have ECU, inverter, motor, sensors, and high voltage batteries, etc. And the function of that item is to deliver requested acceleration or deceleration. So it's something that the driver can feel. A steering system can also be an example of an item. You have the ECU, converter, battery, steering, etc. So when you steer, the vehicle changes direction. Why we would like to have an item that implementing a vehicle level function? Because when you do the HARA, you need to analyze the consequence of a malfunction of an item. And the elements are the systems in the item. So those elements will not give you a observable function at the vehicle level. So when you do the HARA, you have to remember this. You are trying to analyze the malfunction and its consequence at the vehicle level. It is always the malfunction of an item. It's never be the malfunction of an element. If you really mess them up, then you will probably come up with a little bit strange HARA, and then you will conclude some safety goals that are not achievable at the vehicle level. So a reasonable HARA, if you are familiar with this standard or you have done something similar, then the standard simply states that the fire hazard and the electrical shock shall not be covered by this functional safety standard unless it's caused directly by malfunction of an element. So when we have seen the trend in the industry, actually, more and more OEMs are specifying safety requirements related to fire hazard and electrical shock caused hazards. I mean, it's really hard to address those hazards using this standard, because you have to understand that eventually you need to provide some metrics to show that the hardware architecture design is sufficient to reach your safety goal. And so the fire hazard and electrical shock is still under discussion. So it's not necessarily to be a functional failure. I think you can argue that they are the non-functional failure. And so you have a lot of other standards to address those hazards in a much better and efficient way. And also we have seen some crash-related hazards. And to address those issues, the OEM has identified a safety goal with a very, very high ASIL level. And our understanding is that when the OEM doing the HARA, sometimes they overthink a little bit. Because if you really stay within the standard, then a crash can never give you a high exposure rate. The ASIL is determined by 3 factors, and this is defined in the standard. The ASIL is determined by the severity, the exposure, and also the controllability. A crash is an operational situation that doesn't happen often. So if you really follow the standard, then you will see that this kind of hazards can give you highest ASIL A, but we have seen up to ASIL D level safety goal derived by the OEMs. And very similarly, the misuse-related hazards can also never lead to a high ASIL. It's the same reason, because the misuse is not something happens all the time. It cannot give a high exposure, so hence the ASIL level for those safety goals shouldn't be high. But of course, if you really think about some customers intend to, not only customers, also we did the same mistake at the beginning. You intend to think about the consequence of a failure. So you see that if there is a situation that can cause an accident, then you will think that, okay, maybe we should have a higher ASIL for that safety goal. But sometimes it is kind of a conservative and also subjective thinking. If you follow the standard, then you shouldn't have such high ASIL. And safety goals, ASIL, and the safety states. So the safety goal is always to minimize the risk, to reduce the risk to an acceptable level. And I mentioned it before, the ASIL level of that safety goal that is determined by a HARA. And the safe state is an operational state that the vehicle needs to be in order to avoid an accident from happening. So when we do this, when we are deriving the HARA, safety goal, safe states, etc., we need to put on the vehicle engineer's hat. And also remember, there's always a driver behind the steering wheel. So some examples of the safe states. So the item shall be in this state in case of a malfunction of the item. So the driver or other item can avoid an incident. So for example, we have a traction system that can cause too high acceleration. and then the too high acceleration may cause an accident, because it's believed that majority of the driver may not be able to handle this situation. So you could crash into the vehicle driving in front of you. And so the strategy is that, okay, then the item shall stop producing this high acceleration. So the driver can stop the vehicle by the road with the steering and the braking. And so when you design the functional safety concept, you also have to think about other items, not just the traction system. So the vehicle designer needs to think about some other situations as well. So if the vehicle is designed in a way that a common cause fault in the system can cause failures in the traction system, steering system, and the brake system at the same time, then simply this vehicle is designed in a way that there is no achievable safe state. So I will bring this topic again and see what you should think at the functional safety level later on, and how should you address those issues at a proper level. So functional safety level and technical safety level. So when we have done the HARA, and when you have derived the safety goals, associated the issue level, and also the strategy to mitigate those risks, now it's time to start your conceptual development. And the first one you need to do is a so-called functional safety concept. So it is a activity usually performed by the vehicle integrators. So when you design the functional safety concept, you have some cars to play with, and those cars are the items. Those are the systems where we used in your item. So it's time to put on our own hats. So when you do the functional safety developments, the systems are black boxes. But of course, the electrical engineers have a broader knowledge usually. So when they start the functional safety concept developments, they kind of know what is inside those black boxes. And the common thing you do is that you start to open the box and then think what could go wrong in those boxes. And then you start to see things. You can assume some failure modes inside that box, and then you start to specify requirements and then allocate it to the supplier, which is fine to do. However, sometimes you are distracted, and then you start to develop further. So actually, you are helping the supplier to design their technical safety concept. And the technical safety concept is something you design. When you open the box, you start to put components in that box, and then to realize functionalities required by your customer. Maybe it's hard to understand, but what I can tell you is when you mix up the definition of functional safety and technical safety, things can become complicated, because all of a sudden the supplier will require very, very detailed specification, not just description with some numbers. I can show you what we are expecting to have from our customers later. So it's absolutely appreciated to talk about the technical solutions, but it's more appreciated to talk about the functional safety concept and your concerns about the malfunctions in our product. So we can help you to identify all the problems, potential problems that could happen on our side. So we can improve. You can tell us the feedback. What is the top level effects you think that we will cause? So then we can improve our design to improve the overall functional safety. And also, one thing is that when the customer is integrating a safety element out of context, where you can call it out-of-the-shop product into the vehicle. Then one hint is that the functional safety concept needs to be developed while considering the technical safety concept of that safety element out of context. Because if you need changes in the technical safety concept of a element, then it's no longer a safety element out of context. So all of a sudden, the scope of the project is changed. It's something that some of the customers cannot realize. So a thorough functional safety concept. So I talked about the functional safety concept a lot previously, and I'm going to talk a little bit more again, because you can never overstress the importance of having a very thorough functional safety concept. So when you design the conceptual concepts of the vehicle, you have to think about the bigger picture. So as a system integrator, you have the possibility to use many, many awesome systems. So if you do it in a, in a perfect way, so you can really, really simplify the lives for all other system suppliers. This is because that if you try to allocate all the safety requirements to one element, then sometimes not all the requirements are achievable. And sometimes, even if they are achievable, the complexity will be very, very high. Because when you simplify the functional concept design, you are actually not simplifying you are not removing the complexity from the overall system. The complexity simply moves from the functional level down to the technical level. And if you look at what is inside that black box, you see many more components. So we have many, many more functions we have to address. Adding something to an already complicated system can cause a lot of problem. And also, as I mentioned before, if the functional safety requirements is not simply a description with some numbers, it's a fault tolerance time interval. You have to think about part 5 of the standard, the hardware development, because eventually we have to provide you those calculations, the single point fault matrix, latent fault matrix, etc. So we need to know what is your budget, because you know better what are the rest of the systems in the vehicle. Maybe we share the budget together. So if this is not clearly communicated, then we may have some problem at the end of the project. And of course, sometimes it's really difficult to come up with those budget at the conceptual phase. So then it will be really, really appreciated if we can look at the hardware together. So then we can help you to identify the budgets. So some example of a overly simplified functional safety concept design and a more appropriate concept design. So this example is not 100% realistic, I would say. I have to use some extreme examples to show the importance. But we have seen something very, very similar. So the example here is a steering system. So then the malfunction of this item is that the steering system is locked. The hazard is that the vehicle cannot be controlled. And safety goal is very straightforward. We should avoid a locked steering system. A safe state is that we shall unlock it. So if you have a steering system, it's super cheap and simple. However, if this steering system has lost the supply voltage or too low supply voltage, it may lead to a locked steering system. Maybe there's something as bad as this, or maybe it's an engineer who assumed that this can happen. Then the next thing you realize is that, okay, since the safe state is to unlock the steering system, we must have the logic supply to the steering system all time. So then you will allocate the functional safety requirement to this converter, saying that you must ensure to provide a voltage minimum at this level. Otherwise, you violate our safety goal. And the consequence of this one is this DC-DC converter will be designed in a very complicated way because it needs to be fail operational. Otherwise, there's no way you can avoid violating your safety goal. And if you look at the example below, so there we choose a better steering system. This system itself has the low voltage protection. So it is designed in a way that if the logic supply is gone, it will go to a safe state, and that safe state ensures you to not have a locked steering system. I'm not a vehicle engineer, but I assume most of the steering system is designed in this way. So if I have a system like that in this item, then you will see that the DC-DC converter doesn't need to be fail operational any longer. You could implement a voltage supervision in that system, and it can make it safer. It's not even necessary to have the voltage supervision if you have a smarter design, but you can still have it. And then you have a safety mechanism to detect a latent fault in this element. It seems like it has more systems, but maybe the cost is lower in the lower example. So functional safety requirement expectation. As a supplier, we expect to see a more detailed requirement from the customer. And the reason I have mentioned a couple of times in the presentation already is that we produce both the hardware and also the software. And we need to calculate the hardware architecture matrices for you, because eventually you will ask us to provide those calculations. So in order to design our system in a way to fulfill those targets, we need to know the budget first. And also when we receive requirements, it will be so much better if you can provide a little bit more information, such as, is this a requirement for a intended function? Or is this requirement for a safety mechanism that need to be implemented? And these two will make a huge difference when we're calculating the hardware architecture metrics and also the random hardware failures. Okay, and avoid late changes. So it's kind of common to have changes in the project, of course, but it really depends on the type of the changes in the functional safety project. Something I can mention is that change in the functional safety concept can be a disaster, especially at the end of the project, because there are just so many things you have to change. Even changes in the nominal functions, or some customers prefer to call them QM function may result in unexpected results. So I find some examples to show you what I mean. So changes in the functional safety concept, very likely, we need to change the technical safety concept. And this may result in hardware changes. And every hardware change will delay the project significantly. It also may result in massive updates in the work products. Because if you look at the standard, you need to produce dozens of work products for a project. It's a lot of work. So some examples, a QM project turns into a ASIL level project. Could be an ASIL A, could be an ASIL B, usually. And the reason could be that, the end users suddenly realize that they need a safer vehicle. And then the system integrator needs to make the whole system safer. And then they need to talk to the supplier to make that happen. And it's not a problem if we talk about it at the beginning of the project, because we need to come up with a plan. We also have to have agreements in the development interface. But if this happens in the very late stage of the project, then it makes things very complicated. Another one could be that a safety mechanism is identified later. A new hazard is identified. And this could be due to a not completed HARA and the functional safety concept design. I also have some examples about the changes in the nominal function that can cause problems. So we have got a request that we shall implement a fast discharge using motor windings. So at the vehicle level, it's really hard to see why this is a safety-related changes. But the fact is that this changes in traction control in motor, and that is controlling the motors. So adding this one gives the safety impact in the safety concept. So it's not a QM change any longer. And sometimes we have received requests to implement a workaround due to quality issues in other systems, like a bed sensor. And we need to do something to mute some of the diagnostic in order to really use the vehicle. But the things that the OEM doesn't see is that those sensors are also used in the technical safety concept. So a QM change all of a sudden becomes a safety change, which can really impact the project delivery. Okay, so that's the things that I was planning to talk. I managed to finish it. Thank you very much.
Thank you, Shuang. And we have some questions from the floor as well. So thank you for posting those to us. So let's start with the first one. Can you describe a little bit more about the trends that you see in the vehicle industry when it comes to safety and how that is solved in the vehicle architecture?
Well, the functional safety is not new any longer. And the first version of the 26262 standard was released back in 2011. So it's been around for more than a decade. So there's lots of suppliers who have developed something really good, smart, that can facilitate your vehicle integration. For example, the Infineon MCU. So that is developed to be compliant to up to ASIL D project. So lots of things are already inside the system. And also we have launched some safety element out of the context solution. The thing is, when you are trying to integrate those systems, you have to realize one thing is that those systems are developed based on assumptions. those are developed for particular use case, sometimes use cases. So when you are integrating and design a vehicle, you really have to check, is my use case matching the assumed use case?
Okay.
If it does not, then okay, probably I need to find some workaround or some configuration or implementing something extra, or talk to the supplier. Can you make some changes? Well, of course, that will becomes quite costly. So
and we try to avoid cost
yes.
in the automotive industry.
Yeah,
definitely.
Yes, the trend is that okay, there are more and more compliant systems. So you have a lots of options to design something at the vehicle level. So check what is available on the market first. Maybe that's a approach.
Yeah. So more standardized systems or support in the components are already available. So, and that we can project that is also increasing, I would say. So you come to market much faster instead of developing the solution yourself.
Yes.
Great, thank you. And we have some more questions as well. So with the trend of AI coming into play in the automotive industry, will this affect safety and if it does, in what way do you think?
It depends on how do you use the AI. So if you're talking about using AI to facilitate the development, then I would say that there's a trend. And so a lot of tools start to support AI. So you could improve your requirements writing, for example, using AI. So we're going to have some kind of introduction from a tool supplier to us. So we use that tool to handle our requirements. And now they are trying to integrate AI to help us to check the consistency of the requirement, how to write the correct words, etc. And also to check the code. It's not perfect, so you have to be careful. And also it's a kind of difficult to really argue that you can 100% trust the AI. I don't think it's easy to qualify that tool, but it's a good help, I would say.
So currently we're on the GPT-4 models, and so that will have one level, but in the future we will have more advanced. So it will help in the development and checking the consistency of the code and the correctness of the implementation. So eventually that will lead to more safe solutions or secure safety solutions.
Potentially.
Potentially. We don't know yet what's going to happen in vehicle, or do you have any comment on that?
I mean,
with the software.
I had this discussion with some colleagues. So lots of people start to talk about the functional safety and autonomous driving. And then lots of people think that autonomous driving can make functional safety really hard.
Okay.
But I have another opinion, because if you look at the standard and when you calculate the HARA, you consider three things: severity, exposure, and the controllability. And the severity and the exposure has nothing to do with who behind the wheel. It's pretty much depends on your hazard event, the consequence of that. But the controllability, that is the driver. So you have a good controllability if you say that most of the driver can handle that hazard situation. So autonomous driving, I think the AI will be a much better driver than us. So to me, it'll be weird to think that the AI is a worse driver that can give you worse controllability. If the AI gives you a better controllability, then the ASIL level will be reduced.
Mhm.
In the worst case, it will be same as a manned vehicle.
So going from potentially D to A then, or
Maybe,
No.
but it really depends on the vehicle design, because then you really have to make sure that the AI driver never fail.
Mm.
It's like the driver.
Yeah.
The driver needs to be there. Yeah, but then it's not a requirement on the functional safety. It's something else, I would say.
Okay. Good. Thank you for that. And we have time for some more questions. So let's see here. System thinking seems to be the real key to success in designing a safety system, rather than components, looking at the overall system. What, in your view, are the two most important key action a vehicle manufacturer shall consider to be successful in a project? If you only select two out of all the things.
Well, it's based on my assumption. Maybe it's not true. Maybe this is not what is happening in the industry. My assumption is that it is the electrical engineer who's behind everything and who's doing the functional safety development. But actually, I'm an electrical engineer myself. I don't have a good domain knowledge about the vehicle as a whole. I don't know what are the systems available and what they do to help the drivers. So I think that's more important, that we should bring in the competence with respect to the vehicle level design. And those competence could be from the conventional vehicle experts as well. So it feels like something is missing there. And also at the system design level, I mean, one thing I can say is that try to be objective with this standard. It's good to think a little bit more, but if you are too subjective, then you kind of being conservative in the same way. And being conservative is kind of very common, especially in the first iteration of your full stack development.
And might be very costly as well.
Yes, and for sure it will be more costly.
So yeah, good. Thank you for that. And more questions here in the chat is safety mechanism and safety function. You touched on that today.
Yes.
Are very important to differentiate. What should I do as someone that, or as it says here in the text, do as a vehicle manufacturer in order to do it right? How should I think when it comes to the safety functions and the safety mechanism?
Ideally, as a vehicle designer, you don't think about the safety mechanism. You specify what you want to have from those systems. Like in the traction system, the inverter shall provide expected PWM pattern to control the motor. Then the inverter plus the motor together shall give me the torque I would like to have at the vehicle level. So then we will tell you that we have a malfunction. We could produce a little bit too much, a little bit too low. Then the functional safety requirements could be that, okay, in case that you detect, first you shall monitor the torque, or the functional safety requirement shall be that provide the expected torque. And then we do the rest. Because we will do the analysis. We see that we have more functions. We could produce a little bit more, a little bit low. Then we will come up with a technical solution for you. You tell us that, okay, this is the intended function you want to achieve. So if you fail this function, I can tell you, deliver too much torque will violate my safety goal. Deliver opposite torque will violate my safety goal. then we understand a single point fault can cause this malfunction in our system is not allowed. We have to do something. And you tell me this is A to C safety goal, then I also understand that, okay, I have a safety mechanism to detect this malfunction in my system. If I have a failure in this safety mechanism, it's also not okay. I have to do something for you.
Okay.
That's enough. So you don't need to specify what safety mechanisms we need.
So involve, what you're also saying is involve the system supplier in this, in the HARA and in the analysis. Otherwise, you will come up with a solution that is not suitable.
Yes,
for
and
all
sometimes
parts of the system.
the OEM specify some technical solution for us.
Mm.
Please check your temperature. Please check the speed, the interface, etc. Thank you very much. We understand, but sometimes we do it in slightly another way. We simply do not rely on those signals. Specifying safety requirements for those detection will cause confusion because we don't know why you need this. You could use it to implement a safety mechanism at a higher level. Should I do something for you or not? If I do something for you, then the cost will be increased.
Good. We have time for the last question. We spoke about the severity, exposure, and controllability that the vehicle designer must be thinking of during the process. And the default mode should be the safe state. It sounds really logical and simple, but why is it not always like that, that you get one safe state as default mode? Is it due to the complexity of the vehicle, or is it due to bad design, or is it...
If you only talk about the traction system, then you only have one safe state. That's quite straightforward, but not all the items are like that. You may have some quite sophisticated items because you have so many safety critical systems on the vehicle. You have the indication lights, you have the main beams, you have a steering, braking, some other things that I even haven't heard about. So, and also it really depends on your use case. Like driving a personal vehicle or a lorry or a distribution truck or firefighter truck, etc. For the same hazard event, you will come up with a different safety goal with a different ASIL level. So the safe states can be a little bit different. If I have a failure that only requires stop it somewhere without doing anything, fine. But for some of the application, that is not sufficient even. So it's really hard to have a default safe state.
So it depends, safe state depends on the application of rather than the technical solution.
Yes.
Good. Thank you very much, Shuang, for a very good presentation, and thank you all the audience for all the good questions that you put in the chat. So we would like to say that you can go back to the lobby now and then continue for the next session. Thank you very much. Thank you.